Hey guys, today we are solving LeetCode number 662 problem, which is the maximum width of a binary tree. Maximum width is something where, for example, we take example of this example where the width is this, like this is the width where we assume this as a complete binary tree. We assume it as a complete binary tree, then we calculate the width is the number of nodes between the two nodes, between two end nodes. It can be a null node also, doesn't care. We think as a complete binary tree. We can read it also. Given a root in a binary tree, return the maximum width of a given tree. The maximum width of tree is the maximum width among all levels. Yeah, all levels, between the all levels. Okay. So we need a maximum width. See, what you are getting now, you just like make it a thing. Like you would forget also. So max width, let us call it as 0 because there will be some width. If it is not 0 will be our answer, but 1 is our answer. Yeah, 1 would be our for null. Yeah, 0. So the width of one level is defined as the length between the n nodes, the left and rightmost non-null nodes. Yeah, okay. One thing for sure we haven't understood is that the length between the n nodes, leftmost and rightmost null nodes, where the null nodes between the n nodes that would be present in a complete binary tree extending down to that level are also counted to the length calculation. Scanty, the answer will be the range of 32-bit signed integer. Got it? Signed or unsigned? I think unsigned, because it is the count only, the number of nodes in a tree, something very large. Yeah, so we have to typecast, we have to store the indexes as our unsigned long. Yeah, nodes value doesn't matter, number of nodes matters, because see, for a complete binary tree, here would be to the power 0 nodes, to the power 1 nodes, to the power 3 nodes. That means, sorry, 2 nodes, 4, and to the power 3 nodes. That is 8 nodes. Yeah, got it. So, what we can make out of it? We have to think. Yeah. Um. Yeah. Okay. Let us make. See, we are first of all, one thing for sure we are doing is um, level order traversal. Second thing for sure is that we have to typecast it in unsigned long. Yeah, we need the indexes also. Q with index of CVT. Yeah. Oh, let us make a queue with pair of the what, pair of our node, tree node, and unsigned long long long. Yeah. If there is error, we'll make it uh, in the like make error. It will help you. Why? Why we made a queue with a node and the see? We need only the end nodes. Yeah, we'll make it by see written here that end nodes. The width will be start na end minus start plus 1. Yeah, that's how you calculate the width. Yeah, for example, here you take example 0 2 3 4 5 6. So 0 1 2 3 4 5. So 0 1 2 3 4 5 6. 6 minus 3 plus 1 is 4. So 4 is the width, maximum width out of the levels, which may have null as our node. Okay. Yeah, so let's do this. We have made the queue. We do it all the time. Then what we do, then we push. Let us push the root and assign it as 0. Yeah, for the first indexes, while q dot size greater than 0, we have to just find the start node. Yeah, sorry, start index int start index would be what would be our what see all the time we first of all make the thing for the root only, then we move on to the left part and the right part and the yeah, in all the thing, in all level order also. If you see nicely in the level order also you use the same thing. Also for the indexes we use this thing. Don't use int is not required now. Yeah, because it is of the order of which can with int's bound range, it exceeds the range of what int. So we use the unsigned long s is the queue's front, second. Yeah, for the end back second. We can calculate the width. Yeah, max width equals max of our max width and s e minus s, sorry, e minus s plus 1. Yeah, for example for 0th thing, s is 0, e is 0, is 1, max width is 1 now. Next we will move to the left part or the right part. Yeah, Now we are going to the left part. Yeah, also for the left part or the right part, you have to be like getting the all at once. Yeah, you have to push at once all elements. So for int I zero to level size, we can say current size, queue size, we can say int size equals q dot size. I less than size I plus plus. Let us make the current. Why use auto? Because it would help us to get both the index as well as the node. Yeah, current would be our q dot front, then just pop it, and if currents left, currents first, left is not null, then push um push currents first left, and the index, yeah, currents second. Is the index. So int, yeah, um, currents second multiplied by 2 plus 1. So the same thing. It might be overwhelming for the first time, but when you understand this concept, you will be very intrigued to learn this. And lastly, return max width. Let's see what is happening with us. What's the problem? What? No matching function to call max. Wait, I think the bracket is making some problem. Okay, got you. Typecast it to int. Let us write down this problem to understand it better. Yeah. Now, see, 1, 3, 2, 5, 3, nothing, null, and 9. Yeah. So first of all, we are making maximum width as 0. Yeah. Next we make a queue, no problem, with a pair of node and unsigned long, that is our index, because it makes it makes it the uh, range of int in CBT, and the nodes given is too much, like the 3000. For example, if you take example um, skewed binary tree, then it is like the straight line, then the number of nodes would be 2 to the power 3000. Yeah, that's too much, that's int max, it exceeding the int max. Then we are using this type of typecasts. Okay, this type of data identifier. So see, then we make a queue. Okay, we have pushed the root, that is 1, with along with its index as 0. Yeah, then we made a loop where the size of the queue is 1. We make a size that is 1. We have s that's front's second, that is 0, ends. Yeah, would be from the back, from the front, from the back. Okay, from the back second would be like the also 0. So maximum width will be our what, 1, from this formula and all this thing. Then we make a loop from 0 to the size of the current, what do you call, current level. Yeah, we make a current q dot front, we just pop it. If current's first left is not null, then we just push that current first left, that is 3, along with the current's second, that is our 0. 0 into 2 plus 1 is 1, obviously. So this is, yeah. Then if current's first right is not null, push current's first right, that is 2, as well as the index, that is 2. Yeah, then yeah, the size is completed from the 0 to the current level size is what, 1, 0, 1. No, for 0 only. Less than 0, okay, got it. Then you make then again our size is about 2. Yeah, then start is our what, start is would be 1 and end would be 2. Yeah, then s e minus s is 1 plus 1 is 2, make it 2, maximum width will be 2. Then we will be for I0 to what, 2, current will be this q front, this thing, yeah. Then we just pop it, okay. For currents left, push it along with its 3, and also the right path, that is 3 and 4, okay. Then we again go to this, now then again current will be our those front, that is 2 2, yeah, because again it would occur for loop, yeah. Pop it, then for this also 9 will come along with its index, that is 6, I think. We get from the back, yeah, we get from the back, the maximum width will be our calculated. I think now the all will be null, na, then popped all the elements and the size will be what size will be 0, then return maximum width. That's how we get the answer. It's very easy, but yeah, thanks. Like, share, subscribe and comment. I will be posting another video for binary trees, and we will be moving on to the binary search trees, yeah, after that video, one video, last video, okay.